So in this last unit that we're covering this year, before we start preparing for our EOC review, we're talking about transformations. In today's lesson, we're talking about translations and reflections. Before we get into that, however, we want to make sure that we're all speaking the same language when we're talking about transformation. First of all, realize that a transformation is, as you can see in the definition, I'm changing where it is, I'm changing kind of what it looks like as far as maybe I'm turning it, or I'm flipping it, or I'm shrinking or expanding it. We'll talk about all of those different kinds of transformations over the course of the next few days. When we do that, the first thing, the original figure, is our pre-image. And then what we end up with is our image. So you might hear me talk in terms of before and after. That's pre-image and image. When the pre-image is congruent to its image, that makes the transformation an isometry. So we talked about, or I mentioned, that we're going to be talking about taking a figure and moving it. If I take a figure and I move it, is that an isometry, yes or no? Yes. The pre-image is congruent to the image. I just moved it. How about if I flip it? Is that an isometry? Yes. All I've done is, once again, kind of move it. It's still congruent. Same thing with if I'm turning it, a rotation. That is an isometry. I would hope that you'd realize just by virtue of my saying it, if I'm shrinking something or expanding something, that is not an isometry. So, in problem 1, very, very straightforward. Is this an isometry, yes or no? Yes. The pre-image is congruent to the image. And I know it's listed as a your turn, but let's go ahead and get it out of the way. Is that your turn also an isometry? No, the pre-image is smaller than the image. In problem 2, I have A prime, B prime, C prime. Please be familiar with the way that we talk about images versus pre-image. So let's see. The A prime, B prime, C prime is an image of A, B, C, and we're asked what are the images of angle A and B, and we're asked what are the pairs of the corresponding sides. So what I'm asking you is, what does angle A correspond to in its other figure? A prime. Same idea with angle B. It corresponds to angle B prime. Pairs of corresponding sides is going to sound very familiar. We did this before when we were talking about congruent triangles. It's the same exact idea. Segment AB corresponds to segment A prime, B prime. And you've probably already figured out the other two. Segment BC corresponds to B prime, C prime, and AC to A prime, C prime. So all we're doing here is just kind of laying down the groundwork for the vocabulary we're going to be using. In today's lesson, we're talking about dilations, in which the pre-image is not congruent to the image. It is, however, similar. Okay, so we're dealing with enlarging something or reducing something. And just like in Chapter 7, when we were talking about similar figures, those similar figures had a scale factor. So, by the same token, when we're talking about a dilation will also have a scale factor. You want to be really, really careful when you're identifying or when you're calculating the scale factor that you remember, as indicated in your notes, it's, for example, A prime B prime over AB. Another way to put it, you might want to jot it down in your notes, is new over old. The scale factor will be the ratio of the new length over the old length. The new coordinate, perhaps, over the old coordinate. So in problem 1, they're telling us that A prime, B prime, C prime is a dilation of triangle ABC. The center of the dilation is the origin, and for our purposes in this course, the origin will always be the center of the dilation, and that makes our calculations wildly easy. So in the first part of the problem, it's asking us, is the dilation an enlargement or a reduction? You want to be really careful, again, about looking at which one is the original and which one is the new. So ABC is the original, A prime, B prime, C prime is the new. So what is this? An enlargement or a reduction? It's a reduction. That's just a visual assessment. And since I said before that the scale factor is the length of a new segment over the length of an old segment, you might be looking at that and thinking, oh no, do I have to find the length of segment A prime, B prime using distance formula and the length of AB and then set up a ratio? And yeah, you could, but you'd be making your life a whole lot harder than you need to. Because our center of dilation is the origin, does it make sense that we can just use the coordinates and the ratio of one of the new coordinates over its corresponding old coordinate? Okay, so what I mean by that is, let's pick a point and its image. So B, which is located at 4, 5, and B prime, which very annoyingly is located at, be careful, 2, notice the scale, 2, 2.5. Notice the scale of the coordinate plane. Each box is representing 2. Okay, so since I told you that scale factor is calculated by taking new over old, looking at these coordinates, what do you think is our scale factor? New over old. I heard it. Say it again, Isa. It's 1/2. If I just look at those x-coordinates, new is 2, old is 4, reduces to 1/2. There it is. Yes, ma'am. Okay, because 0, 0 is our center of dilation,